Hello my dear students, and this is here Kiran, and today in this video we are going to look into a different topic. Actually I was thought of starting with lens formula, but before going into lens formula, this topic plays an important role in deriving lens formula. So that is the reason why I've chosen this a refraction at a spherical surface topic. Else I would have already started with the lens formula. Okay, so let's get back into this topic now. So what is refraction at a spherical surface? Why this derivation is more important in relation with lens maker's formula? Okay, so let me draw a ray diagram and then I'll continue with this. Just a minute, let me draw and I'll resume the recording. Okay, listen here, guys. Whenever light travels from rarer medium to denser medium, it refracts. We know that, right? So to which medium it is getting into, in that medium the refraction takes place. So here I'm telling that light is traveling from rarer medium to denser medium, so refraction takes place in the denser medium. And also we know that laws of refraction, like incident ray, normal ray. See, this is the thing. If this is the mirror, suppose if this is the mirror, according to law of refraction, if you draw a perpendicular line to the mirror or a lens, it is called as a normal ray. So this is a normal ray, this is an incident ray, and this is a refracted ray. So incident ray, normal ray, refracted ray all meet at the same point. Okay, so here in this refraction at a spherical surface topic, we need to draw a normal line. So only then we can proceed with the rest of the derivation. So how can we draw a normal line? It is very simple. If you draw a straight line which passes through the center of curvature, it can be considered as a normal line, because for a curved surface, from any side, if you draw a line and that is called, that is always perpendicular, so and those lines are said to be in normal lines. So you can draw n number of lines, but to this spherical surface we can draw three normal lines. Wait, let me draw that. So this is the real ray diagram. This is the aperture. Aperture is nothing but total diameter of the lens or the mirror through which the light enters. Okay. How DSLR camera has its aperture which can be controlled automatically. So similarly, this is called as an aperture. MN. In this part, the center part of the spherical surface is P. Okay, so we'll make it like this. Okay, suppose if this is the, if you mark it as a imaginary sphere, it will have its center, right? It will have its center. So this is center. So PC is called radius. Okay, fine. Now I'll start with the object and everything. I'm placing an object here, object. So before that I have to draw a normal line. I told you, right? I forgot it. Listen here. If you draw a line that passes through center of curvature, then that can be considered as normal line. So here this is a normal line, and similarly even you can draw from point N, and here I should start from M. I'll mark it MS here. Okay, fine. So MC and NC makes the normal line. Okay, next is, so if this is the incident ray, if this is the incident ray and incident angle, after incidence it undergoes refraction, right? Since light is entering from rarer medium of refractive index N1 to denser medium, this is a glass, right? This is a denser medium with a refractive index N2. It always bend towards normal. It bend towards normal and meet at a point where it forms an image. Similarly, here also it happens. It is not necessary to draw at the below part, but for symmetric we are doing this. Okay, right? So let's mark angles here, different angles. Listen, this be a theta 1, theta 2, and this is theta 3. Okay, so if this is angle of incidence, then this is called angle of refraction. Am I right? Okay, so all these things are over. Let's move on to Cartesian sign convention here. So Cartesian sign convention is the object is placed on the left hand side, so the object distance is OP, it is U. Next, image is formed on the right hand side, so the image distance is PI, that is plus V. Radius of curvature is PC, even that is on the right hand side, so that is plus R. So we have written all Cartesian sign convention for object, image and radius of curvature here. Okay, so let's move on to the topic now. And also as I've already mentioned in the mirror formula video, if you draw a perpendicular line from M to P, it won't make any much difference in the answer, because the curvature is very small, so you can make it as a perpendicular line for considering this is right angle triangle. Okay, fine. So let's derive a relationship between object image relationship of an spherical mirror here. So let's write all the angles here to avoid confusion. MOP is theta 1, MCP is theta 2, and MIP is theta 3. Okay, and here we are going to find the angle for three different triangles, right angle triangles. Listen, and first I am going to take this right angle triangle MOP. Okay, so MOP is nothing but this one, right? Just compare with the original diagram. This is M, P, O, and this is theta 1. And for this, I am going to find tan theta 1 opposite PM divided by adjacent is PO. So 1 is over. And next one, MCP. For right angle triangle, MCP, I am following the same procedure. So this is C, M, P, and this is theta 2. So here it goes like this. Tan theta 2 is equal to PM divided by PM divided by PC. Okay, next is last triangle is MIP, and this is theta 3, I, and this is P. And again I am going to find theta 3, that is opposite PM divided by adjacent is PI. So here I am going to make a very big difference. Like if the aperture is very larger when compared to the object distance and the image distance, I'm drawing, see with this diagram, the diagram which I've already drawn here, you cannot understand from this. I'll draw it separately here. Suppose if the aperture is very larger and the object distance and image distance, this is object distance and image distance, is very smaller, then angle is very small. Angle will be very small. So instead of writing theta 1, you can simply mark it as theta 1. Tan theta 1, you can mark it as theta 1. Okay, so I'm just scoring out this and writing it as simply theta 1. Since angle is very small, you need not write tan or sine or cos. So you can simply mark it as theta 1, theta 2 in theta 3. Are you clear now? Okay. Fine. So next part is, let's find angle of incidence. So angle of incidence is I here, right? So I is at an exterior angle. It is an exterior angle, right? It is outside the triangle. So if you want to find an exterior angle, the geometrical identity is, exterior angle is nothing but sum of interior opposite angles. Sum of interior opposite angles. And here sum of interior opposite angle is theta 1 plus theta 2. Okay. So I is equal to, what is theta 1? Theta 1 is Pm divided by Po plus Pm divided by Pc. Similarly, if you want to find refraction, angle of refraction, it is already here. See, it is already here. If you find angle of refraction, and you have to take sum of difference of corresponding angles, that is theta 2 minus theta 3. So theta 2 is Pm divided by Pc minus Pm divided by Pi. Okay. We have to apply all these in Lenz's formula, Lenz's law. And you may ask, what is Lenz's law? Lenz's law is very simple. Ratio of sine of angle of incidence to its sine of angle of refraction is always constant, which is called as a refractive index. So that is 2, 1. That is, light travels from rarer medium, that is 1, and it is getting refracted in the second medium 2. Okay, so n2. I'm expanding this, sine I divided by sine R is equal to n2 divided by n1. Let me cross multiply this. n1 sine I is equal to n2 sine R. As we have already seen in this part, since angle is very small, tan theta can be written as theta, simply theta, right? So if tan theta can be simply written as theta, even sine can be written as just I. Sine I can be written as I, because the angle is very small here. So anyway, you need not to use this sign convention, that is a natural sine or natural cos or natural tan, to find an angle. So simply it can be rewritten as theta. So here I am rewriting this as simply I, and here as simply R. I can substitute all these I values and R values in this part, n into, and here you can write it as Pm divided by Pc plus Pm divided by sign to, I have made a mistake, Pm divided by Po here. Po, okay. Po, Pm divided by Pc is equal to n2 into Pm divided by Pc minus Pm divided by Pi. I am taking Pm as common term. So 1 divided by Po plus 1 divided by Pc is equal to n2 into 1 divided by Pc minus 1 divided by Pi. Okay. Here also I am taking Pm as common. So Pm get cancelled. So n1 into 1 divided by Po plus 1 divided by Pc is equal to n2 into 1 divided by Pc minus 1 divided by Pi. Are you okay now? Okay. Let's substitute the Cartesian sign convention here. I'm deleting this part for my convenience to write. Okay. So I'm going to see, this is the Po plus 1 divided by Pc is equal to n2 into 1 divided by Pc minus 1 divided by Pi. Let me substitute all Cartesian sign convention here. 1 divided by Po is minus u plus 1 divided by PC is R, radius of curvature, N2. 1 divided by PC is R, minus 1 divided by Pi is image distance V. So I'm going to multiply this N1 divided by minus U plus N1 divided by R is equal to N2 divided by R minus N2 divided by V. So let's rewrite all these things. This can be brought here and this can be brought to this side. So what we'll get is N2 divided by V minus N1 divided by U is equal to N2 divided by R minus N1 divided by R. So the final answer, it goes like this, that is N2 divided by V minus N1 divided by U is equal to N2 minus N1 whole divided by R. So this is the relationship between U, V and R for refraction at a spherical surface. And with this video, with this final result, it will be easy for you to derive lens formula for any kind of an lens, whether it is an concave lens or convex lens. So this result, this relation plays a predominant role in bringing lens formula. Okay, so thank you very much. If there is any doubt or query related to this topic, and please do drop your queries in the comment box so that I can answer you in another video. And thank you very much for watching this. Until then, it's bye from your Kiran.